If 10 married couples are randomly seated at a round table, compute the expected number and the variance of the number of wives that are seated next to their husbands. So, the first thing that you want to do, the keyword is the expected number of the number of wives, right? So you know that the random variable has to pertain to the number of wives, right? So let x be the number of wives seated next to their husbands. Right? So essentially what you want to do, you want to let x be equal to x1 plus x2 plus etc until the last x10. So you're actually counting each individual random variable. Right? So for this reason, each random variable can have value 1 or 0. Right? Because if it's equal to 1, then the total count will be 10. If it's equal to 0, or some of them will equal to 0, obviously your result x will be less than 10. It will be some integer less than 10, 9, 8, 7, or 6, or 5, etc. Right? So for this reason, you're going to let xi be equal to either 1 or 0. 1 if the ith wife sits next to her husband. And 0 otherwise. Okay? So now we're looking for expected value, right? Because that's the first thing that we need to find, the expected number of wives that are seated next to their husbands. Right? So the expected value of the random variable will be the sum of all expected values from 1 to 10 of the exi. Right? So it means that you're going to add each expected value of each random variable, right? 1, 2, etc., until the last one. Okay, so now let's find each of them. Let's take e of x1. As you know, the expected value is equal to x1 in this case times the probability of the x1 being equal to 1. Well, I'm just gonna do that, right? So as you know here, the x1 can be 0 or 1. So if in case if it's 0, it's gonna be that, and then the separate case is when, and it's a separate case because it cannot work simultaneously. That's why you have to add a separate case, right? The separate case is always added. Plus when x1 is equal to 1 and not 0 but 1 times the probability of the random variable being equal to 1. Right? So we can disregard the 0 because we can disregard the probability, finding the probability, because this is going to be 0 anyway, right? So we can just worry about that. 1 can be disregarded because it's just 1, right? So it's the probability of x1 being equal to 1. So now, what is the probability of the first wife being seated next to her husband? Right? We know that her husband takes 1 seat out of the 10 seats because there are 10 married couples. Right? There are 20 seats in total. So I'm gonna write that 20 seats in total. Right? So 20 seats in total. The husband takes 1 seat. What is the probability of his wife sitting next to him? Right? If the husband's seated, he's seated here. Then there are 2 seats around him, right? And there are 19 seats in total that the wife can take, and there are 2 around him. Right, so the probability that she's sitting next to him is going to be 2 out of the available 19 seats. Right, so it's going to be 2, 19. So that's the expected value of the x1. So now what about the expected value of the others? Well, the expected value of the others is all going to be the same, right? So we can say that the expected value of 1 is equal to the expected value of 2, because the expected value of 2 is going to be the same thing, 0 times the p of x2 is equal to 0, which is going to be 0, and then essentially plus 1 times p x2 being equal to 1, right? Because we disregarded the 0 because that's negligible. And again, we set the xi. Remember, the xi can be 1 or 0. So 1, that's why you see that 1 in there, because we don't want the 0, right? We disregarded it. So 1, and the probability of the second wife being seated next to her husband, when you're looking at her for the first time, suppose that this is the second wife's husband now, the same probability, because she can seat around him in 2 ways, right? In 1 seat and or this second seat, right? 2 seats available out of the 19. So that's going to be still 219, right? So all of these expected values, the first one, the second one, and all the way to the 10th, are all equal, right? So this expected values are all equal. So basically, the expected value that you wanted to find, this one here, is going to be summing up 219s 10 times, right? So 219 10 times 219, right? Because there will be 10 219s, so you might as well just multiply the 219 times 10, which is giving you 2019. So that is the expected number of wives that are seated next to their husbands, right? 20 over 19. So you can expect that a little over 1 wives are seated next to her husbands, right? So it means that we expect that at least 1 wife will be seated next to her husband if we look at the couples randomly, right? So now, the second part, it's a much longer part and more work to do, is the variance. Okay, so the variance of x is going to be the summation from 1 to 10 of the variance of xi, okay, plus 2 I is less than j covariance of xi xj, right? So now we have to do some work to find both of these. Okay, so first let's actually find the covariance. Okay, so the covariance, so I'm gonna do this work here. The covariance of xi and xj is going to be equal to the expected value of the product xi xj minus the product of the individual expected values of xi and xj. So recall now that in the same way that we've done work here for the expected values, you will multiply these two, like here the random variable was by itself, here you would multiply, and again you're talking about the ones only because the zeros will turn everything to 0. So you will essentially be talking about the 1 times 1 is 1, and the probability of xi times probability of xj being equal to 1 in the case when the random variables are equal to 1, right? So essentially you're talking about the probability of xi being equal to 1 and the probability of xj being equal to 1, right? So you can notate that as the probability, well, let me do it here, the probability of xi being equal to 1 and of xj being equal to 1 minus, and here again, just as the work we've done here, we know that this part is equal to essentially two probabilities multiplying, right? So the probability of xi equal to 1 times the probability of xj being equal to 1. Okay? So now recall from Bayes' formula that this part can be written as probability of xj being equal to 1 given xi being equal to 1 times probability of xi being equal to 1. Right, and we're placing the conditional on the I first because ith wife comes before the jth wife, right? If we're talking about the ordering. That's why the conditional is the I first and then the j. Given that the I, what about the j after that, right? So, and then minus this part here, I is equal to 1 times the probability of xj is equal to 1. Okay, so we have to calculate this part, right? So what is the probability of xj being equal to 1 given xi is equal to 1? Right, so I'm going to draw the circle so that we can understand what it is. So basically what it says is that you already have a couple. The ith wife is sitting next to her husband, the probability of that. So you already have a couple sitting together. And then you're trying to see what is the probability of the jth wife sitting next to her husband. So suppose that, and there are two cases. There are two cases that we will sum up in the same way that we've summed up here. Okay, two separate cases. So the first case is that the jth wife is sitting next to the couple. So suppose that she's sitting here or here. So there are 20 seats in total, so she has 18 seats to choose from, and 2 of them will be next to the couple. So the chance that she's sitting next to the couple is going to be 2 out of the 18 seats available. Write that a little larger, 218. And we will multiply that to the probability that the husband, the jth husband, is sitting next to his jth wife. Right? Because this is the probability that we have to find given that the ith wife is sitting next to her husband. Given that the probability of the ith wife is sitting next to her husband. Right? So so what is the chance that her husband is sitting next to her? There's only 1 seat available out of the 17 seats, right? So 3 seats are taken already because the jth wife took the seat as well, so there's 17 available now, and the husband has only 1 to sit next to his wife, right? So it's going to be 1 over 17. Right? So that's equal to what? That's equal to well, no, I didn't do the second case. So the second case now that we have to add is going to be if the jth wife is not sitting next to the couple. If she's sitting somewhere else, like if she's sitting here, then the jth husband has 2 seats around his jth wife and not just 1, right? So now, first of all, what is the chance that she's sitting here out of the 20 seats available. Now notice that we're not going to be talking about her sitting next to the couple now. She's going to be sitting in the remaining 16 seats, in one of the 16 seats, right? So we're not talking about 2 seats around the couple that's already there. So we have to subtract 4 seats. So 20 minus 4 is 16. So 1 out of 16 chance that she's sitting somewhere here and not next to the couple, right? So yes, so 16 seats available out of the 18, right? So 18 seats for her to sit in, but 2 seats that she cannot take next to the couple, right? So it's going to be 16 over 18 probability that she's sitting somewhere here and not next to the couple. Now for the husband, he can sit in any 2 seats around his jth wife now, the jth husband, right? So it's going to be 17 seats available, and 2 of them are next to his wife. So it's going to be 2 times 17 this time, right? So 2 separate cases, which yields you, if you do the algebra right, it's going to be equal to 1/9. Okay, so we found this part. So now this is going to be pretty easy, right? So let's see. So the probability of the jth wife sitting next to her husband, given the ith wife sitting next to her husband, times the probability of the ith wife sitting next to her husband minus the product ith wife sitting next to her husband times the jth wife sitting next to her husband is going to be 1/9 times, now we already found this probability, the probability of xi is equal to 1 is going to be what? 219, right? 219 times 1 was still 219. So 219 minus the 219 squared, right? Because these two probabilities are each of them is 219, right? So 219 squared, right? Okay, so now that is the covariance that we just found. That is the covariance. So that's equal to 2 over 171 minus 219 squared. Okay, so that's the covariance that we found. So now we have to find this part, because we kind of found the covariance, and I'm going to explain this summation part later. But let's find the summation of the variance here. So this is equal to well, I'm not gonna let me not do summation first. Let's actually just do the variance of xi itself. As you know, this is equal to the expected value of the squared of the random variable xi minus the square of the expected value itself, right? So basically what it means is that you're going to have now again, we're going to only note when xi is equal to 1. So 1 squared times the probability of one random variable squared is equal to 1. So 1 squared times the probability of xi squared is equal to 1, right? Minus and again, each exi was equal to 219, right? So we were basically squaring the 219, right? And as you know, this is equal to 1 squared is 1, and xi squared is equal to 1 means that you will have xi is equal to 1 if you take the square root, right, on both sides. You're going to be having only 1 or minus 1. There's no way that the xi is minus 1. It can only be 0 or 1, right? So in this case, so you're talking about the probability, essentially, that xi is equal to 1 minus 219 squared, which is equal to what? 219 minus 219 squared, right? Because this is equal to 219, as we've noticed before here, right? So 219 minus 219 squared, so 219 minus 219 squared. So now the sum of those variances, we have to sum up this variance that we found 10 times, right? From I is equal to 1 to 10, right? So this is essentially 10 times, well, I don't have space for here, is essentially 10 times this 219 minus that. Alright, so we found this component. Now it remains to find what this means. So I is less than j means that you're going to be talking about pairings. So I is going to be starting from 1 because there are 10, right? There are 10. I starts from 1 to 10, right? 1 to 10. So when I is equal to 1, j has to be greater than I, right? And they're all coming in integers, right? 1, 2, 3, 4, 5 until 10. So j can be 2, 3, etc., until 10. So how many pairings are there? 9 pairings. When I is equal to 2, j has to be greater, so j will be 3, 4, all the way until 10. How many pairings is that? 8 pairings. And etc., it will just keep decreasing by 1, the number of pairings. Right? So there will be keep 7, etc., So this is going to be equal to what? This is going to be equal to 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 until there's one pairing, right? So that's going to be what? 17 plus 7, 24. Well, let me add it this way. 17 plus 10, 6 plus 4 is 27, plus 12 is 39, plus 6 is 45. 45 pairings. Right? So essentially you're talking about choosing any two from the 10, right? You're talking about combinations. So the shortcut is to do NCR, 10, choose 2, which in notation means 10 to choose 2, which can be written as 10 factorial over 2 factorial times the difference of 10 and 2 factorial, which is 8 factorial, right? Which is equal to 10 times 9 over 2 times 1, which is equal to 90 over 2. Bingo. Same result, 45. Right? So the variance, adding all components up in that formula, is going to be 10 times, like this part first, right? The summation of all the variances, 219 minus the square, plus twice the double summation which is found, which is 45, times the covariance we found here, 2 over 171 minus 2 over 19 squared. Now it takes a lot to actually simplify this, but you can simplify this to a single fraction and it will yield you this result, 360 over 361. Let me write that a little better. 360 over 361. So that's going to be your found variance of the number of wives that are seated next to their husbands. Thank you so much for watching. Hope this was helpful. See you in the next videos.